Now, for our third example, the problem is the heights of teachers in Santa Catalina National High School are normally distributed with a mean of 150 centimeters and the standard deviation of 15 centimeters. The height of Sir Victor has a z-score of 3.25. What is the actual height of Sir Victor? So in this problem, we are not going to find the z-score because it's already given, which is the z-score of height of Sir Victor, which is equals to 3.25. So what is the actual height that is the conversion that has a conversion of z-score 3.25? So that is what we are going to find out. So for the solution of example 3, we have here the given. So the mean height, the average height of all the teachers in Santa Catalina National High School is 150 centimeters. Standard deviation is 15, and z-score is specific for Sir Victor. Sir Victor's height is equals to 3.25. So we are going to find the x, or the height of Sir Victor. So for the solution, we have here the formula x equals to mu plus z times standard deviation. So this formula were already presented earlier in our illustration. So we have the x, or the scores, the value will be accumulated by adding your mean to the multiple, or the z-score of your standard deviation. So we already showed that in our first example earlier. So now we can substitute the value of our mean, the z-score, and the standard deviation. So we have here 150 for the height, average height, 150 centimeters plus 3.25 times the standard deviation of 15 centimeters. And we have 150 plus 3.25 times 15, that is equals to 48.75 centimeter. And lastly, just add these two, and we have equals to 198.75 centimeters. So this is how tall Sir Victor is. His height, actual height, is 198.75 centimeter, given a z-score of 3.25 from our normal distribution in their heights in Santa Catalina National High School. Now, for our fourth example, let's have this problem. The time it takes for a cell to divide is normally distributed with an average of 60 minutes and standard deviation of 5 minutes. How long will it take for a given cell to divide if its mitosis has a z-score of negative 1.35? So this problem revolves concept in our science, which is cell division. So we have given values, the mean, which is also the average, 60 minutes, standard deviation, 5 minutes, and we are going to find the z-score for a given cell, for the time it takes for a given cell to divide if it's mitosis. So let's find out. Again, here are the given. Mu is equals to 60 minutes. Standard deviation, 5 minutes. Z, we have equals to negative 1.35. So we are going to find again the time it takes for the cell to divide in mitosis. So the x. So for the solution, again, we have x equals to mu plus z times standard deviation. So let's substitute 60 minutes for the mu or the mean plus negative 1.35, which is the z-score, times 5 minutes, the standard deviation. So we have here negative sign for our z-score, so do not forget to input it, because negative multiplies by the positive will inculcates to negative value. So negative 1.35 times 5, that is equals to negative 6.75, and it will be added to 60 minutes, which is the average. Then 60 minus 6.75, that is equals to 53.25 minutes. That means this is the time it will take for the cell to divide in mitosis. And for our last problem in conversion of the z values or to standard values to the normal values, so and vice versa, we have here the last problem. Suppose you have the population values 40 and 70, and that their corresponding z-scores are negative 2 and positive 1 respectively. First question, is it possible to determine the population's mean and standard deviation? Second, if so, what are these values? So in this problem, we have given population values or the x values. So we have two groups and their z-scores, corresponding z-scores. So we are going to find the mean and the standard deviation for this problem. If it's possible to get it, we are going to find it. So let us try. So our given values, population values, we have x sub 1, which is equals to 40, and x sub 2, which is equals to 70. So we then notate it with sub 1 and sub 2 since there are two groups. And the z-score for 40, we have negative 2, and the z sub 2 is equals to 1. So we are going to find the mean and the standard deviation, or our mu and the sigma. So again, our solution here, since we are going to find the x value, the mean and standard deviation, we can use the formula wherein we can get the x. So in here, we'll be having equations, two equations, linear systems. So let's substitute our x sub 1 with its corresponding z sub 1. So our x sub 1 is equals to 40 equals to mu minus 2, because negative 2 is our z sub 1 multiplied by the standard deviation. Since there are two values that we are going to find, so we cannot just easily get it in this equation. So we are going to have another equation from this set of values. So we have the x sub 2 equals to mu. So we are going to find out if they have the same mean and standard deviation. So the mu plus z sub 2 and standard deviation. And the given for x sub 2 is 70 equals to mu plus 1, which is the z-score, z sub 2 times standard deviation, or simply standard deviation here, sigma. So let's solve these two equations. So we have two equations, two unknowns, which is mu and standard deviation. Let us note that in this example, we do not have the sigma 1 and sigma 2 and mu 1 and mu 2, since we are describing a simple population. Thus, we can assume that this standard deviation for the data 1 and the data 2 is equals, and the same with their mean. For the solution, we need to have the equation 1 and our equation 2. So equation 1 is 40 equals to mu minus 2 sigma, and equation 2, 70 equals to mu plus 1 sigma. So when we recall our linear systems, how to simplify those and find the solution. So in here, we're going to find the solution of the mean and the standard deviation. So we can use a technique or a method which is elimination. So how can we do that? We are going to subtract the equation 1 from equation 2. So we have an invisible minus to our equation 1 here. So minus 40 equals to mu minus 2 sigma. So we have negative 40, or 70 minus 40 rather, that is equals to 30. Then mu times mu minus mu, that is equals to 0. So we eliminated the mu. And we have 1 minus negative 2 sigma. So they have same variable, which is sigma. So let's just get the coefficient. 1 minus negative 2, that is equals to 3. So we have plus 3 sigma here. So we already eliminated the mu, and we have here the equation 30 equals to 0 or 3q. So let us simplify. So again, we have here the difference of the two equations. 30 equals to 3 sigma. So let's simplify and multiply 1/3 to both sides of the equation. So multiply 1/3 to 30, we have equals to 10. So 30 times 1 divided by 3, that is equals to 10. Then 3 sigma times 1, that is 3 sigma divided by 3, that is equals to sigma. So this is the simplified form or the value of our standard deviation. Now, how can we get the mean? So we have already the standard deviation. So let us substitute the value of standard deviation to our equation. So now, let us substitute the value of our sigma or the standard deviation to our two equations to determine the mean or the average. So let's have here our first equation. 40 is equals to mu minus 2 sigma. So we substitute 10 to our standard deviation. 40 is equals to mu minus 2 times 10. So we have equals to 20 here. So we have minus 20 here. Then we transpose negative 20 to the left side. So we have 40 plus, it will become positive. That's why 40 plus 20 is equals to 60. So that is equals to mu or the mean. For our second equation, let's substitute and see what will be the mean. So for the second equation, we have 70 is equals to mu plus 1 sigma or simply sigma. Then substitute 10 to our sigma. We will be having 70 is equals to mu plus 1 times 10, that is equals 1 times 10, that is equals to 10. Then substitute positive 10 to the left side. We have 70, it will become negative minus 10. So 70 minus 10, that is equals to 60, also equals to me. So that means with the given with the standard deviation that we've got from the substitution, from the elimination, which is 10, we already get the value of the mean, which is 60 through substitution. And in conclusion, to answer the questions we have, the two questions we have in this problem, example 5, so therefore, the question first, is it possible? So the answer, it's possible to determine the population's mean and standard deviation given only the raw score or our x values and its corresponding standard score or our z-score. So it's possible. Just make sure that you'll be having 2 or more equations if you have 2 or more unknowns. And the given obtained value for the mean and the standard deviation of the population are 60 and 10. So we have 60 for the mean, so we have here, and 10 for the standard deviation. So that's it for our lesson 7, which is about the conversion of the normal variable to the standard normal variable.